My name is Jean-Francois Gaillard. I'm from Northwestern University, and I've come to UNSAM for starting these exchange programs in between our universities. So my research group is primarily interested in looking at metals in the environment. In particular, we're looking at metals biouptake by prokaryotes, microorganisms. Some of these microorganisms are able to transform some metals, in particular mercury, into more toxic compounds which are neurotoxic and form something which is called monomethyl mercury. And that comes to play in terms of it's bioaccumulated through the food web, and you find this monomethyl mercury in fish. And what happens then is that it's given a certain concentration of this contaminant. It's a very potent neurotoxic, and it can engender a lot of neurotoxicological problems. And some other metals also have antimicrobial properties. And so in my group, what we're interested in is looking how these metals get inside these cells. And the other part is to really look at how metals can be recovered from our past activities, from mine tailings, from actually landfills, you name it. So it's basically an idea of to be able to recover the metals, to reuse them, and in order to promote some kind of circular economy. When you're talking about mercury, it's a global pollutant. So basically it can be generated most of the time by burning coal. So it's very distributed globally. Not that much in the southern hemisphere, but in the northern hemisphere there are large contamination coming from burning of coal in China and in India, also in the US. In the case of mercury, there are local sources, right? Because, for example, in the Amazonas, they are doing a lot of mining, gold mining, using mercury. So in terms of the exchange, what I notice is that people are working on metals here, in particular metals which are coming out from landfills or urban contamination. One of the things that we do in my group is looking at what's called chemical speciation to do an analysis that gives us the different forms under which the metals are present. So in the case of some metals, there are some chemical forms which are more toxic than others. And then there are ways of also immobilizing these metals inside the sediments so that they cannot be redistributed into the water column.